Hi students, welcome to TIME. In this session, we will be discussing about the questions related to types of motion, scalar and vector quantities in the chapter Kinematics. Hope the concepts related to these topics, types of motion, scalar and vector quantities are clear for you. If at all you have any doubts related to these particular topics, I suggest you to visit that particular part of the video of the concepts and make the concepts clear, and then come over here to watch this particular video where we discuss the questions. Okay. Let us begin with the test your basics questions. Okay. In this test your basics, we will go with the fill in the blanks. Clear? First one on screen. An object without extent is called. What do you call this? Yes, it is right. It is a point object. Object without extent, there is no extent, it is a point object. Clear? If it has an extent, it will be called as an extended object. Very clear. Let us move on to the next question. According to the theory proposed by Copernicus, dash and all other planets orbit around dash. We have two blanks over here. Copernican theory. What is the Copernican theory called? Heliocentric theory, right? So, when you refer to the word heliocentric theory, dash and other planets orbit around what? Exactly. So, first one he is talking about the Earth, and all other planets orbit around what? Sun, because the word helio refers to the sun. Clear? So, the answers are Earth and the Sun. Clear? Let us move on to the next question. Dash and rest are relative words. Very clear. So, this is the motion. Motion and rest are relative words. Let us move on to the next question. Motion of a pulley used in drawing water from a well is an example of dash motion. So, how does the pulley move when you are drawing water? Yes, it is an example of rotational motion. Clear? Let us see the next question on screen. If a vector P makes an angle theta with the horizontal, then its component along x-axis is. Let us draw a rough sketch of this particular figure of the situation. Okay. So, I will take, okay, this is the y-axis, this is the x-axis. Okay, let me draw, this is x and this is y. Okay. And this is from the origin. P makes an angle theta. So, what will I do is, I draw vector like this making an angle theta. This is the vector P. Now, if this vector makes an angle theta, I want the component of x along this. So, what will I do? I will take different components. I will draw a perpendicular onto the x-axis. So, if I take the component on the perpendicular onto the x-axis, let me mark this is A and this is B, right. So, let me take this BA as say y and this OA as x. Now, y will represent the vertical component and x will represent the horizontal component. The question is about the horizontal component here. So, how do I see if OB is representing the vector P, OA will represent the horizontal component. I want the relation between this OA and OB. Clear? So, OA, that is x, is the adjacent side for this particular right angle triangle. Right angle is here. This is the right angle. Clear? So, I will have here OA divided by OB. That is nothing but equal to cos theta. Adjacent side divided by hypotenuse. So, OA is nothing but x, x divided by OB is nothing but P is equal to cos theta. So, I will get this as x is equal to P cos theta. So, my answer will be here P cos theta. Is this clear? Let us solve some multiple choice questions. Here the 4 options will be given and you need to correct the select the correct alternative. Clear? So, let us go with the first question. When a car moves forward, the motion of its tires is dash. We have the 4 options given here. Translational, rotational, both 1 and 2, random motion. What do you think about the motion of the tires? When a car is going in the forward direction, tires have to rotate, right? So, when they are rotating, that means they will have rotational motion. But at the same time, they are also going in the forward direction, right? So, this implies that they will have both translational as well as rotational. So, what will be the answer? Yes, it is the both 1 and 2. Clear? So, next one. Let us see the next question here. Motion of the molecules in a gas is an example of dash motion. Motion of the molecules in a gas. Can you specify that, okay, the molecules should move in a particular direction like this only? Is it possible that way? No, right? See the options over here. Translatory, rotatory, oscillatory, random. Translatory is moving in a particular direction. Rotatory moving in a circular path. Okay. Oscillatory moving to and fro about a fixed position. So, will we have the motion of the molecules like this? No. They will go in a random direction. So, the answer is the random direction. Is it clear? Let us go on to the next question. If 2 vectors act as 2 adjacent sides of a triangle taken in order, then the third side taken in the dash order acts as a resultant vector. You have the options over here. Reverse, same, 1 or 2, none of these. Okay. If at all I represent 2 vectors, let me take an example. Suppose I have one vector in this direction. Let us suppose OA is representing one vector. The ending point of this particular vector, okay, will act as a starting point for the second vector. I'll say A to B is representing another vector. Now, I should add these two, OA and AB. So, OA plus AB. So, when I add these two vectorially, what will I get? The starting point of the first vector to the ending point of the second vector. So, I will get it as OB. Is it clear? Now, when this is the one, I have put an arrow over here. This indicates what? Direction of the vector. So, adding these two vectors is giving me this one. That means, this is the resultant vector, right? If this is the resultant vector, from where it is going? From O to B. So, if you see in the figure, we will have the direction from O to B. From here to this one. Okay. This is how I am representing. If this is the case, now this will suit which of the options? Clear, right? It is the reverse order. So, this is the answer. Okay. Two vectors acting the adjacent sides of a triangle. These two are the adjacent sides of a triangle taken in order. Then the third side taken in the reverse order. If it is in the same order, I should say it as OA, AB, and I should say it as BO. But it is not BO, it is O to B. Clear? That is the reason it is called as the reverse order. Clear? So, this is the answer for this. Let us move on to the next question. If magnitude of a vector P is given by, there are 4 choices over here. P and this is mod of P, P bar is there here. This bar on the, there is the arrow above the P indicating that it is a vector quantity. Clear? Then like this, P and both 1 and 2. Whenever I have the vector this way, magnitude will be represented by the modulus symbol on the vector P or without the arrow this way. So, the answer will be both 1 and 2. Clear? Let us move on to the next question. Which of the following shows addition of vectors A and B? So, here I have given 3 images over here. One, the first image is going this way, it is shown this way, you can see the arrows, okay. Second and third. Let us try to animate these things and then observe. First one is going like this, 2 vectors are directly like this, the addition is shown this way. Second one is shown, A and B are like this and the addition is shown this way. Third one like this and the addition is shown this way. The fourth option will be none of these. Is it clear? Now he is asking which of the following shows the addition of vectors A and B, A and B. So how do you add these two? If these two are added, here if you see the first option, the starting point of the first vector to the ending point of the second vector, if I take, that B is not in this direction. It is in the downward direction. So this cannot be the answer. Clear? Next one, second option if you consider, A vector is going from this point to this point. The end point of the vector A begins the starting point of the second vector B, and it is going from this point to this point. Okay. Whereas now if I take the sum of these two vectors, it is starting from the end point of the second vector to the beginning point of the first vector. Is it according to the law? No, right? Let us look at the third one. Here A vector is shown from the black arrow over here. Starting point is here and ending point is this point. Whereas the second vector starts at the end point of A and goes over here. The resultant of these two is given by the starting point of the first vector to the ending point of the second vector. So this gives the correct addition of these two vectors A and B. Clear? This is according to the triangle law of addition of vectors. Is this clear? Hope you are clear with the concepts of types of motion, scalar and vector quantities in the chapter Kinematics. If you are not clear with any of the concepts, I would suggest you to go back to that particular part of the basics video, watch them again and get those concepts clear. Okay. If you are done with the test your basics questions also, then we will proceed here in this particular video with some knowledge based questions. Clear? Let us go with the first question. First question on the screen is, what is kinematics? Just having a recall of what is kinematics. What is it? Yes, it is a branch of mechanics, right? Which will deal with what? Yes, branch of mechanics which will deal with study of the motion of the particles without reference to the cause of their motion. Their motion, cause of their motion will not be discussed in the kinematics. Only will study the motion of the bodies. That's the types of the motion of the bodies. Clear? Let us see the next question on screen. What is the triangle law of vector addition? So when you say triangle law of vector addition, basically we wanted to add two vectors. Okay. These two vectors will be represented by two adjacent sides of a triangle. Let us have a look at the okay. Let us take a vector like this, O to A. Okay. If I am taking the vector O to A and then another vector say A to B. So this vector OA plus the other vector AB, if I wanted to add these two, then the resultant of these two will be given by the line joining O to B. Okay. So this is how we'll get. So it is not from B to A, it is from O to B. So these two sides OA and AB represent the two adjacent sides of a triangle taken in the same order. Okay. Then the resultant of these two, which is given by OB, that means it is given by the third side of the triangle but taken in the reverse order. This will be the triangle law of vector addition. Let us look at the statement of the triangle law. If two vectors are represented by two sides of a triangle taken in order, their resultant is represented by the third side of the triangle taken in the reverse order. Clear? This is the triangle law of vector addition. Let us see the next question on the screen. What is the triangle law of vector addition? Triangle law of vector addition is dealing with the addition of vectors. That is clear. So the statement goes like this: if two vectors are represented by two sides of a triangle taken in order, then their resultant is represented by the third side of the triangle taken in the reverse order. First, suppose I will take one vector AB Okay, this A to B is representing the vector P. Okay, another vector I will take, say, starting from B to C, that is a Q vector. If these two vectors have to be added as per the triangle law, we will have the resultant of these two starting from A to C. So, A to C, if I write take an arrow, then this arrow will represent the sum of these two. So, I will get R is equal to P plus Q. That is the triangle law of addition of vectors. Clear? What is a scalar? Scalar is a physical quantity which requires both magnitude and direction for its complete description. Okay. So, its magnitude does not change with direction at all. It is a constant. Whatever the direction you measure, it will be constant. Any examples? Yes. Temperature, mass, time, length, all these are the scalar quantities. Okay. What is a vector? Vectors are physical quantities which require both magnitude and direction for their complete description. Is it clear? So, here when you talk about the physical quantity which requires both magnitude and direction, one example I will say displacement. If I have a displacement of 5 meter, say along north of east, making some angle, let us take an example to understand that. Okay. If at all I have a vector like this, I will say 5 kilometer is the displacement of the body along north of east. I will say this is the north. Okay. If I take this is the north, this is east, this is south, and this is west. Okay. If I take this way, then I can say that, okay, along, if I take the component of this particular 5 kilometer along, say, east, it will be, say, if it is making an angle 37 degrees, this will be 3 kilometers. Whereas, the vertical component here, it will be equal to 4 kilometers. So, starting point is O, ending point is A. Okay. So, here the displacement of 5 kilometers is north of east. But if I say what is the displacement along east, it will be only 3 kilometers. What is the displacement along north? It is only 4 kilometers. If I say what is the displacement along west? 0. So, what is happening? The magnitude is changing with direction. Clear? That is the reason we need to specify both magnitude as well as direction for its complete description. So, such quantities are called vectors. Hope this is clear. Let us see the next question on screen. Define translatory motion, oscillatory motion. Give 2 examples each. What do you mean by translatory motion? Whenever a body moves in a particular direction, all the particles of the body move in the same direction. Okay. Such motion is called as a translatory motion. Okay. So, going by the definition of the translatory motion, we have the motion in which every particle of the body will be having the same displacement. Okay. Examples, we can take a train moving along its track, motion of a launched rocket, whatever it is. It is going along a straight path. All the particles of the body will be having the same displacement. Coming to the oscillatory motion. When I say oscillatory, the word itself is oscillates, means it is moving to and fro about a fixed position. That type of motion will be called as an oscillatory motion. Let us see the definition of this. The to and fro motion about a fixed point is called the oscillatory or vibratory motion. You can take the example of a pendulum in a clock. In a pendulum clock, you take a pendulum in a pendulum clock, it will be making to and fro oscillations. Whatever the oscillation time takes for one complete oscillation, we will call it as the time period. Generally, for the pendulum clocks, it will be seconds pendulum. If you say for one complete oscillation, it will take 2 seconds of time. So, the motion of that. So, such an examples are for oscillatory motion. Clear? Let us see the next question on the screen. Write any 5 examples of vectors. Come on, you list out what are the vectors. Vector is a physical quantity which requires both magnitude and direction, right? But some examples of vectors. Can I say length? Okay, length can be either distance or displacement. When I say distance, distance is not a vector. Is it clear? displacement is a vector. Okay. So, because displacement requires both magnitude and direction. Some more examples, please. Yes, velocity is there. S, acceleration is there. Let us see the examples. Displacement, velocity, acceleration, momentum, force. So, momentum and force, we will come across them in the other chapters set dynamics, but these are also vectors. Hope you are clear with the concepts of types of motion, scalar and vector quantities in the chapter kinematics. If you are not clear with any of these concepts, I suggest you to go back to that particular part of the basics video, watch those concepts and make the concepts clear. Okay. Hope you are done with the test your basics part of the subtopic. Now, we will proceed with the understanding based questions of this particular subtopic. If you are not yet done answering those questions, I suggest you to pause the video for a while, then answer those questions on your own and then resume watching the video to validate the answers for your questions. Let us see the next question on the screen. Name the type of motion involved in the following: wheels of a bicycle when somebody is riding it, motion of a moving car on a straight road, motion of a pendulum in a pendulum clock. The first one, if you consider A, the motion of the wheels of a bicycle. So, if I consider the bicycle over here, the wheels of a bicycle, okay. So, a person is pedaling it, okay. When the person is pedaling it, what is happening? The wheels will be rotating, going in the forward direction as well as they are also going in the forward direction. So, two types of motion is involved over here. What is that motion? One is the rotational motion, another is the translational motion. So, I can say it is rotational, okay, rotational, comma, translational motion. These are the two types of motion involved in the first case. Second case, if I consider, I am saying motion of a moving car on a straight road. So, if I take a car, okay, it is moving along a straight road, that is it. So, total car as a whole I am considering. When car is moving along a straight road, then the total car will be moving in the same path. All parts of the car will be like the total body of the car will be moving in the same path. So, I can consider it as translational motion. Okay. Translational motion is the motion of the car. Next one, third one, motion of a pendulum in a clock. So, I say, okay, there is a pendulum over there which is suspended from a rigid support. Okay, this pendulum will be oscillating about the mean position. So, if this is the mean position O, here A and B are the extreme positions. Is it clear? So, it is oscillating about these two positions. Clear? So, this one we will call it as the oscillatory motion. Clear? So, these are the types of motion involved in the following cases. Clear? Let us see the next question. Draw a diagram to show the resolution of a vector when it makes an angle 45 degrees with the x-axis. So, let us take, okay, this is the x-axis and y-axis. I am taking a vector OA and which is making an angle 45 degrees with the horizontal. Clear? So, now I want the resolution of this vector along the x-axis and y-axis. Okay. So, I should make a projection onto the x-axis. So, AB will represent the projection of OA onto the x-axis. So, the along the x-axis the component will be OB, along the y-axis the component is OC. Clear? So, from A to C I am dropping a perpendicular onto the y-axis here. Okay. So, this component will be giving me the y component and OB will be giving me the x component. So, I will draw a straight line like this. So, what are the component? If I say P is a vector represented by OA, then O to B, this will be like P cos 45. If I take the y component, it is cos 45. If I take along the y component, that is O to P, O to C, this will be the P sin theta, P sin 45. Clear? Now, you can observe very clearly that the values of sin 45 and cos 45 and sin 45 both are equal. Sin 45 is 1 by root 2, cos 45 is also 1 by root 2. That means, both the horizontal component as well as the vertical component, they will be equal in magnitude. Clear? That is also obvious with the figure OBA. If this angle is 90 degrees for sure, so this is given as 45 degrees. So, what will be this angle? This angle is also equal to 45 degrees. Okay. That means now the triangle OBA is an isosceles right angled triangle. In an isosceles right angled triangle, the sides equal to opposite sides of the the sides opposite to the equal sides of a triangle are equal. That means, here it is 45 degrees, here also it is 45 degrees. When I say isosceles right angle triangle, that means these two sides are equal. That means, AB and OB are equal. AB represents the vertical component, OB represents the horizontal component. So, these two components magnitudes will be equal. So, this is how we will resolve the vector when it is making an angle 45 degrees with the horizontal. Clear? Let us see the next question. Give an example for each. One-dimensional motion, next is two-dimensional motion, and the third one is three-dimensional motion. What do you think of one-dimensional motion? Means the body is moving along a straight path. Clear? It does not deviate in its path, it is going along a straight path. So, I can take the motion of a train along its straight track. Clear? That is example of one-dimensional motion. Coming to the two-dimensional motion means that the body is given, the given body is moving in two different directions at the same time. Clear? If we take an example, for example, if I say there is a cricket field and the batsman is here, the batsman will hit the ball for 6 runs. So, then the ball will be following a path like this. Clear? This is the horizontal, the path followed by it is a curved path. That means, here the body is going in two dimensions. It is going horizontally as well as it is going vertically also. So, this can be a better example for two-dimensional motion. Clear? Now, coming to three-dimensional motion. When I say three-dimensional motion, the body should move in three different directions at the same time. Clear? One of the example is that, say, motion of a honeybee. Honeybee, it goes in a random direction. It does not stick to any one particular direction. Clear? Or else, another example you can take, okay, motion of a plane, once it takes off from the runway, and if it is changing its direction of motion, is it clear? Then that motion can be considered as three-dimensional motion because it is not going only in two directions. It is also going in the third direction at the same time. Clear? As it is taking the, once it is taking the runoff, from the runoff runway, if it is taking the, once the plane is taking off from the runway, is it clear? It is changing its path, then that motion we will consider it as to be the three-dimensional motion. Hope the examples are clear for you. Let us see the next question on the screen. Two forces 4 Newton and 3 Newton are acting on a particle. If the angle between them is 90 degrees, then find the magnitude of the resultant force acting on the particle. So, let us consider one particle over here, and I say there is 4 Newton force acting in one direction. Let me say, okay, this is O and this is A. OA is representing me 4 Newton. Okay, and one more force is acting on the particle, that is 3 Newton. Let us take this way, it is 3 Newton. So, let me represent, okay, B is another point here. OB is representing 3 Newton force. Clear? Now, I want the angle between them is 90 degrees. These two are perpendicular to each other. I want the resultant of these two. So, because both are acting from the same point, both the forces are acting from the same point. If at all I wanted to know the resultant of these two, what will I do is, I will take a component of, the vector along this OA, parallel to it I will take from B. because to add two vectors, the convenient way is to start the second vector from the end point of one vector. So, I will take one vector which is parallel to this one from the point B, okay, or else not only this way, I can also take the other way, like where I will take the parallel one from along OB to from the point A. So, either this direction, let me take this point as C, that means either I can take BC parallel to OA or I can take AC parallel to OB. Now, this is a completed rectangle. If I say O to B is representing 3 Newton and B to C also represents 4 Newton, because B to C, this direction is along the direction of O to A. The length of BC is also equal to the length of OA. So, I can very well say that these two are equal. That means, this is also equal to 4 Newton. Or else, because this OB is 3 Newton, I can say this is A to C is also equal to 3 Newton. Now, either the triangle OBC or the triangle OAC can be considered to find out the resultant. So, we know the triangle law of addition of vectors. According to the triangle law of addition of vectors, if two vectors are represented in magnitude and direction by two adjacent sides of a triangle taken in order, then the resultant of these two will be given by the third side of the triangle taken in the reverse order. If I consider the triangle OBC, now OB, BC and CO will be the sides. Third side is CO. Now, that CO I will take it in the reverse order. Clear? So, if I take the CO in the reverse order, it will become OC. So, O to C will be giving me the direction of the resultant as well as magnitude. So, now 3 Newton, 4 Newton. What will I get the magnitude of O to C? Obviously, I can apply the Pythagoras theorem and then calculate, we will get it as 5 Newton. Clear? So, the resultant of them, the magnitude of the resultant force will be equal to 5 Newton. That is the answer. Let us begin with the first question on the screen. Okay, a given body can be in a state of rest or in a state of motion in a given time. Explain it with an example. So, here we are talking about a body can be in a state of rest and in the state of motion. Let us think a while whether one particular body at the same instant, is it possible for a body to be in a state of rest and in the state of motion also? If it is not possible, right, why is the question here? We can say simply no, right? But here we need to explain with an example. It indicates a clue actually that yes, it is possible to be in a state of rest and in a state of motion. Let us see how. Suppose I say this is a road and here there is a bus stop over here, okay, and here is a tree. Besides, a tree is there. Now, a person standing in the bus stop waiting for the bus, okay, and the tree is here. The tree cannot have translatory motion. It will be in a state of rest with respect to what? The bus stop as well as the person waiting in the bus stop for a bus. Now, suppose I consider a bus moving, okay, on the road. Now, for suppose I will consider this is a bus and this is a bus driver over here. If the bus along with the driver is passing through on the way, is it clear? So, he moves. So, the same person, the bus driver along with the bus is moving, then the person is at rest with respect to the tree, but the same person is in motion with respect to the bus as well as the driver in the bus. We are talking about one body, that is the person. With respect to the tree, he is at rest. at the same instant as the bus is moving forward, the same person is in motion with respect to the driver. So, with respect to what? The reference. If the reference is changing, then the same body can be at rest and also can be in a state of motion at the same instant. Hope you are clear with the concepts of types of motion, scalar and vector quantities in the chapter Kinematics. If you are not clear with any of the concepts, please go to that particular part of the basics video, understand the concepts, and then come back to this particular video where we discuss the application based questions. If you are done with textual basics and the knowledge based and understanding based questions, fine. Otherwise, I suggest you to go through that particular part of the exercises. Do those exercises, watch the corresponding videos for validating your answers with whatever you have done. As far as the application based questions is considered, if you are not yet done with the application based questions, I suggest you to pause the video for a while, do the problems on your own, solve the application based questions, and then again resume watching this video so as to validate your answers. Clear? Let us go with the first question on the application based questions. First question is that when will a scoot rest appear to be stationary with respect to another scoot rest? So here the concept is related to rest and motion. We know that rest and motion are relative. When I say scoot rest appear to be stationary with respect to another scoot rest. When I say scoot rest is there, that means the person driving a scooter. So when I say a person is driving a scooter, that means he is in motion with respect to his surroundings. If I consider a scoot rest A, another scoot rest B. So that means A is moving with certain speed. When will this scoot rest appear to be stationary for another scoot rest B? Obviously, B also should move in the same direction and that too with the same speed. If he is traveling with say VA, the speed of the scoot rest A is VA, then the speed of the scoot rest B is VB, then the condition required for the scoot rest A to be at rest compared to scoot rest B is that VA is equal to VB. When both are traveling in the same direction, then only it is possible that VA is equal to VB. If the magnitude of the speed is equal, but they are traveling in opposite directions, then also we will not say VA is equal to VB. Then we have VA is equal to minus VB. When I say VA is equal to VB, it implies that magnitude as well as direction of motion. Is it clear? Magnitude of the speed as well as direction of motion, both should be identical. Then only we will be able to say that, okay, one scoot rest is at rest with respect to another scoot rest. Hope the solution is clear. Let us move on to the next question. A particle is displaced by 10 meter if one of its rectangular component is 6 meter. What is the other rectangular component? One thing is sure, particle is displaced by 10 meter. So let me take, okay, a particle is displaced by 10 meter. This is the displacement of the particle. Then one of its rectangular component is 6 meter. I don't know what is the angle this makes. Let us assume that I am taking a component, a rectangular component. I will take one rectangular component horizontally. And he is telling that this is 6 meter. Let me take it as OA. OA is 10 meter. Then correspondingly, if I take the rectangular component, say B, O to B if I need to take, let me take clearly. Okay. So, I will take the rectangular component. So, up to this, say this is say 6 meter. This is given. What is the other rectangular component? One component I have taken. Another rectangular component means I need to split this. Okay. One other component I will take vertically. Okay. This component I will take. This component is like I will draw a straight line. So, I want the value of this. So, let me mark it as C. OC and BA both will be equal because this is a rectangular component. OBAC forms a rectangle. So, it is very clear now I can take this value. Let me take this SX, horizontal component, and this as say SY, vertical component. Clear? That means if I add these two, SX plus SY, I should get equal to S. I am writing a bar over here, that means it is a vectorial addition. Okay. So, if I wanted to convey the magnitude wise, then I will say, okay, Sx square plus Sy square is equal to S square. So, here also bar should be there. Sx and Sy, I am adding this to vectorially, I am getting this one. Magnitude wise, if I take Sx square plus Sy square is equal to S square. Out of these two, I will know I have the values of Sx and S. So, this corresponds to S here. Okay. So, now I will say, okay, S square is 10, 10 square is equal to Sy square. Let me write this Sy square only. And what I have, Sx is equal to 6. So, I will have here 6 square. Now, it is very much easy for us to calculate what is the value of Sy, right? So, Sy square will be equal to what? Sy square is equal to 10 square minus 6 square. The easy way to solve this is, see, it is something like a square minus b square. I will take it as a plus b into a minus b. 10 plus 6, 16 into 10 minus 6, 4. Okay, 16 into 4. 16 4s are 64. So, that means it is 64. So, now Sy will be equal to what? Square root of 64, and that is equal to 8 meter. So, 8 meter is the another rectangular component. That is the answer. Is this clear to you? Let us see the next question on the board. Why can't the vectors be added algebraically? When I say algebraical addition, that means only the magnitude wise addition, that's it. Okay. Vector is a physical quantity which involves both magnitude as well as direction. If it is to be added algebraically, only magnitude should be enough. That means the physical quantity should be of a type scalar. Because vectors include both magnitude as well as direction, we will not be able to use the algebraic addition over there. We have to follow the rules of geometrical addition. Clear? Let us see the next question on the board. Can two vectors of different magnitude be combined to give zero resultant? So, for this to understand, first of all, we should understand, right, when do we get a zero resultant? So, zero resultant means, let us suppose if I take a vector A, okay, vector A is there, I should add something to it to get 0. So, what should I add? I should add minus A, that's it. Minus A if I add, then it will be equal to 0 vector. Okay. 0 also I am showing it as a bar above it, so it is a vector. So, I wanted to add these two, then I will get 0. I wanted to have different magnitudes. Now, only under this condition I am getting 0. That means the magnitude of A and magnitude of minus A. We need to consider these two. Clear? Now, the question is that when I am adding these two, I am getting 0. Will the magnitudes of these two vectors be different? If these two are different, then the answer for this question will be yes. Is it clear? So, we are talking about two vectors of different magnitude. When I wanted to have 0, this is the condition to get 0. Now, I need to check out on these particular magnitudes. So, what do you mean by A and minus A? Let us suppose P to Q, these 2 points is representing a vector A. So, direction of A is from P to Q. The length of the line drawn PQ will represent the magnitude of A. Is it clear? That is how we represent a vector. The length of the line drawn to scale will be representing the magnitude of the vector, and the direction will be shown from the starting point to the ending point. So, from P to Q, initial point to terminal point. Now, minus A, if I say minus A means what? The direction is indicating the minus value over here. So, minus A will be from Q to P. That means, from Q it started and ends up to P, then this will become minus A. Is it clear? So, minus A represents Q to P means what? The length of PQ and QP will be equal. When I say the length of PQ and QP both are equal, magnitude is equal. Clear? It is the same line but reversed in the direction. Right? So, when it is the same line reversed in the direction, their lengths are equal. The same line segment, the segment direction is reversed. If it was P to Q, it was A. If it is Q to P, it is minus A. So, the magnitudes of these two are equal, then only I will be able to get 0 vector, which implies that if two vectors of different magnitude, if I wanted to add, I will not be able to get a 0 vector. Clear? If at all I wanted to add two vectors of different magnitude, but still be getting a 0 vector, it is not possible with two vectors. I should take third vector. Clear? Let us look at the next question on the board. The can component of vector be greater than the vector itself? I am taking two components. Suppose I draw a vector like this. Okay, let me represent it as P. P is the vector drawn from the arrow is representing the vector P. So, I wanted to have the components of these two vectors. So, I will take one component along the horizontal. So, from here, if I take the dotted line down, so this will become P cos theta, where theta is the angle made by the vector P with respect to the horizontal. Let me write it as Px. Okay. Similarly, if I take the vertical component, I will get the vertical component this way. Okay. This is equal to P sin theta. So, I will take it as Py is equal to P sin theta. So, Px and Py, these two are the components. Now, if you wanted to know the component of the vector be greater than the vector itself, maybe magnitude if we consider, I want the magnitude of P cos theta be greater than P, or magnitude of P sin theta be greater than P. Okay. So, here something multiplied with P into cos theta or P into sin theta. So, this product, this should be greater than P itself. Is it clear? So, we need to check whether the cos theta values or sin theta values will be greater than 1 or not. Under what conditions? Let us suppose what is the angle variation here? Angle can vary from what? 0 to 90. If the angle is equal to 0, that means this P will be along the horizontal. Then P cos theta will be equal to P. If angle is 90 degrees, then this P will coincide with P sin theta. Okay. Then the magnitude of P sin theta will be equal to P. Now, in between there is some angle theta, then these components too will arise. So, if I take theta is changing from 0 to 90 here. Okay. So, let me take theta greater than 0 and less than 90. These are the possibilities 0 degrees and 90 degrees. This is the possibility for the angle. Then correspondingly sin theta, if I consider sin theta will be less than sin 0 and less than sin 90 here, because as theta varies from 0 to 1, value of sin theta will go from 0 to 1. Sin 90 is equal to 1, sin 0 is 0. Clear? So, if theta lies between these two, yes, sin theta will lie between 0 and 1. Now, cos theta, if I consider cos theta, it will be here cos 0 and here it is cos 90 as per the values of theta and 90. Now, it is not like sine, but it is cos. Cos function will be like cosine function. So, cos 0 is equal to 1. So, this is 1 over here and this is 0 over here. That means what? If cos 0 it is greater than cos theta and cos theta is greater than cos 90. So, when theta is lying between 0 and 90 degrees, cos value will vary from 1 and 0. Okay. I am taking any angle between 0 and 90. Even sin theta lies between 0 and 1. Cos theta is also lying between 0 and 1. That means it is a fraction. So, a number multiplied with a fraction will be always less than the original number. Yes or no? So, same way here, p cos theta, when theta is lying between 0 and 90, will be less than p itself. Okay. Similarly, p sin theta also, when theta is lying between 0 and 90, p into sin theta will be less than p. So, if you multiply here p sin theta will be greater than 0, but less than p sin 90. Same way here, p cos theta, if I write like this, p sin theta, okay. So, here it will be less than 0, but here it is p into 1. P sin theta is less than p. Here if I say p cos theta, okay, it is greater than 0, but it is less than 1 into p. So, p cos theta is less than p sin theta is also less than p. So, the components of a vector can never be greater than the vector itself. Hope the concepts of the topics, the types of motion scalar and vector quantities is clear to you. If at all any of the concept is not clear, I suggest you to go back to that particular part of the video, okay, observe the concepts and then become strong in those concepts. Hope you are also done with the texture basics as well as the skill builder exercise questions also. Now, in this particular video, we will proceed with the practice questions. Before you watch this particular video of practice questions, I suggest you to do these questions, attempt these questions on your own. If you are not yet done, pause the video for a while and then practice those questions on your own. Then again, you can come back and resume watching the video for the practice questions. Okay. Let us move on to the first question in the practice questions. Okay. Two vectors of magnitudes 3 meter and 4 meter are at 90 degrees with each other. Then what is the magnitude of the resultant vector? Okay. Very clearly telling two vectors of magnitudes 3 meter and 4 meter. Let us take one vector, say 3 meter like this. And another vector of 4 meter should be at 90 degrees to each other. So, I will take it perpendicularly, another vector 4 meter. The angle between them is 90 degrees. Is it clear? Now, I wanted to know the magnitude of the resultant vector. How do I get the resultant of these two? So, this is going in the vertical direction, say magnitude 4 meter. The 3 meter vector is in the horizontal direction. Okay. So, for that, I need to first complete the rectangle, because these two are at 90 degrees to each other. If I complete the figure, I will get a rectangle. So, to complete the rectangle, I will take the component of this particular thing and then horizontal line like this. Okay. And for 3 meter also, I will take one more line parallel to this in the upward direction. this forms a complete rectangle now. When two vectors are going from the same point, starting from the same point, okay, if I mark this as OA, OA is representing me 3 meter and say OB is representing me 4 meter, and this BC, if I write the C as here, so B to C is equivalent to OA, which is having 3 meter. Okay. Similarly, A to C also is having 4 meter, which is equivalent to OB. Now, if at all I wanted to calculate the resultant of these two vectors, that means I should add these two vectors geometrically so that it can be obtained by the triangle law of addition of vectors. Okay. So, what does the triangle law of addition of vectors say? If two vectors are represented in magnitude and direction by two adjacent sides of a triangle, where is the triangle over here? Triangle is not there, right? It is a rectangle. So, can be obtained by, as the statement proceeds, two vectors, if two vectors are represented in magnitude and direction by two adjacent sides of a triangle taken in order. If I say OA and AC are the two sides of a triangle taken in order, then the resultant is given in magnitude and direction by the third side of the triangle taken in the reverse order. That means, if I join this O to C, that will be the third side of the triangle OAC taken in the reverse order. If I take CO, it is in the same order. I am taking OC in the reverse order. I need not take only this triangle OAC. I can also take triangle OBC also. So, OB plus BC is giving me OC. Either ways I will get. So, if I wanted to calculate what is the magnitude, simple, I should use a Pythagoras theorem. So, 3 square plus 4 square, 3 square plus 4 square, and square root of that will be giving me what is the length OC. And what is this magnitude? Obviously, it is 5 meter. We know very well 3 square is 9, 4 square is 16, 16 plus 9 is equal to 25, and square root of 25 is 5. Clear? So, 5 meter will be the magnitude of this particular resultant vector. Is this clear? Let us see the next question on the screen. Is the component of a vector a vector? Give reason. This is a little bit skeptical question. When I say component of a vector, what do you mean by component of vector? If I take any vector, let us say like this, if I am taking a vector, say P, shown by an arrow, and this vector is making some angle theta with respect to the horizontal, then the component, if I consider along the horizontal, it will be P cos theta. Okay. And along the vertical, if I take, this will be along, say this is P sin theta. Now, the question is related to this P cos theta and P sin theta. So, the question asks whether these two are also vectors. Is it clear? When I am writing P cos theta, I am just taking the component magnitude only. Okay. So, if at all I wanted to write Px as the x component of this, and if I represent this as Py, okay, then if at all I wanted to write this way, Px plus Py is equal to P, okay, it implies that, okay, I am adding these two, I am getting the resultant. So, addition of Px and Py is giving me P. In this sense, if you consider, it will appear as if Px and Py are also vectors. Okay. But when I am writing this way, Px and bar above, okay, this will be a vector. But when I say Px simply like this is not a vector. Why? Because the difference between this Px bar and this Px is that I am associating a vector along the direction of Px. That means P cos theta into a unit vector associated along the x direction. If I am If I am attaching a unit vector along with px, then I can write it as px bar. Then only it will become a vector. Okay. Similarly, py bar, that means what? P sin theta associated with it, I am taking a vector. That vector magnitude is 1. Okay. Unit vector I am taking. Because magnitude is 1, it is a unit vector. Unit vector in what direction? Y direction. Okay. If I take the unit vector in the y direction, multiply that with the p sin theta, then I can write it as py bar. No doubt px bar and py bar are vectors. When it is px bar, only when a unit vector associated in the x direction is associated with it. Is it clear? If I write, for example, I cap is the vector in the x direction. Let me write this way. Because it is a unit vector, I am writing it like a cap. I cap is a unit vector. So then it will be like px into I plus py into j. J is a unit vector what I am taking along the y axis. I am representing the unit vector along x axis as I bar, I cap or I bar, whatever you can write. And similarly, j bar or j cap is a vector along the y direction. If I write like this, then as I can say it is vector. Now, this px, this py is different from px bar and py bar. If it is this px and py, these two are not vectors. Clear? So, these two components, and if at all I say px bar, this px bar is not a component of p. It is a vector along x axis. So, why it is a vector? I am associating a vector I along with px. Is it clear? So, it is not just a component, it is a vector in itself. Similarly, py bar is a vector in itself. I am adding this to, I am getting this. Clear? So, ultimately, the bottom line is that the component of a vector cannot be a vector. Clear? Let us see the next question on the screen. Sort out scalars and vectors from the following: displacement, acceleration, momentum, force, velocity, speed, impulse, pressure, area, volume. Certain things are given here. So, if we wanted to sort them out into vectors and scalars, we need to identify that which is a vector and which is a scalar. We need to identify that which physical quantity requires both magnitude and direction to describe it completely, because that is the basis of a vector, right? The basic definition of a vector is that a physical quantity which requires both magnitude as well as direction for its complete description. Clear? If it is not required, that means magnitude alone is enough, direction is not required at all for its complete description, then it will be a scalar. So, what are the physical quantities you see now? Displacement, change in the position. How do you measure it? We also need to have magnitude as well as direction. Clear? So, that will be a vector. Acceleration, then velocity. Velocity also requires both magnitude and direction for its complete description. Velocity is a vector not because it is displacement by time. Okay, we cannot say, okay, this velocity is rate of displacement according to the formula displacement divided by time. Displacement is a vector, time is a scalar. So, velocity we are getting by a vector by a scalar. There is an operation between a scalar and a vector, therefore, it is a vector. We should not jump into conclusion like that. We have to identify a vector or a scalar only by the property of whether that particular physical quantity requires both magnitude and direction for its complete description or not. If it is requiring, yes, it is a vector. If it is not requiring, then it is a scalar. Clear? Based on the bench rule, if you consider, we have these components set: displacement, acceleration, momentum, force, velocity and impulse. These quantities will be the vectors. If you wanted to measure the volume, area, pressure or speed, is it clear? They don't require direction for their description. Only magnitude is enough. So, the other quantities So, these are scalars. Okay. These are all scalars, rest all these highlighted things are the vectors. Is this clear? Let us see the next question. What are the differences between scalar and a vector? So, scalar and vector, basically the difference is that, okay, if I write scalar here and vector, okay. So, scalar by definition is a physical quantity which requires only magnitude for its complete description. Okay, only magnitude is enough to describe it. Whereas here, vectors require both magnitude and direction. Magnitude and direction. These two are required. Okay, that is one thing. Second point is that, okay, second point is that when you wanted to add or subtract vectors, you can go with algebraic operations, algebraic addition. Okay. Whereas in the case of vectors, it should be geometric addition. The things, they cannot be added algebraically, it is geometric addition. Okay. We need to have special rules to follow the addition of vectors or a subtraction of vectors. Okay. So, these are the major differences between the scalar and vector. Thank you for watching.